1. The first descent into gravitational darkness. A black hole begins not as a monster, but as a quiet transformation in the heart of a dying star. In its final moments, the star gently exhausts its nuclear fuel, and the balance between outward pressure and inward gravity slips into stillness. What follows is not chaos, but a serene collapse, a soft folding of matter inward, as if the fabric of the star simply allows itself to rest. Layer by layer, pressure deepens, density increases, and matter approaches a point where the familiar rules of existence lose their meaning. This descent is calm, like a deep exhale into darkness. Nothing resists, nothing escapes. Everything settles into one infinitely small point of quiet gravity. From millions of miles away, the star that once burned with brilliant light becomes an invisible well, where space curves inward with graceful precision. This is the beginning of a black hole, a gateway shaped not through violence, but through a natural return to gravitational stillness. The cosmos does not mark its birth with sound or color. It simply shifts. A new gravitational presence emerges, silent and patient, ready to shape the flow of time and light around it for billions of years. 2. The horizon, where light pauses forever. The event horizon is one of the most poetic boundaries in the universe. A place where even light can only hover, unable to return. Approaching this boundary feels nothing like reaching a physical wall. There's no texture, no barrier, no sudden change. Instead, space gradually curves inward, as if inviting the traveler into deeper quiet. Time stretches softly, slowing with each step toward the horizon. To an outside observer, the traveler appears to fade, suspended indefinitely in a single moment, stretched thin across time. Yet from the traveler's own perspective, movement continues naturally, smoothly, without interruption. The event horizon is a veil woven from the fabric of space-time, marking a gentle threshold beyond which the universe keeps its secrets. Light bends around it in delicate arcs, circling before finally succumbing to the inward pull. Every photon that touches this sphere becomes part of the black hole's silent archive, stored on the surface like a faint imprint in space-time. The horizon is a cosmic whisper, a boundary defined not by what it contains, but by what it releases. Nothing at all. 3. The singularity, a point beyond meaning. Deep within the black hole rests the singularity, a place where the concept of place dissolves. It is not a point in the traditional sense, nor a location that one could ever visit or meaningfully describe. It is a destination of infinite density, where matter compresses into a state that defies the language of physics. Here, the curvature of space-time becomes immeasurable, collapsing into a depth so profound that even time ceases to have direction. The singularity is the quietest realm imaginable, not because nothing happens, but because the usual framework of happening disappears. It exists like a philosophical boundary, a conceptual edge where reality folds into silence. Protected behind the horizon, it remains forever invisible, forever abstract, yet its influence shapes everything above it. The singularity anchors the black hole's gravity, guiding the path of falling stars, drifting dust, and bending beams of light. Though unreachable, it is one of the universe's deepest meditations, an endless point of stillness where existence narrows into pure gravity. 4. The soft curvature of spacetime. Gravity is not a force, but a shape, a gentle bending of the universe's geometry. A black hole is simply the deepest curve of all, a smooth valley carved into spacetime. objects do not fall inward because they are pulled, but because the path of least resistance guides them there. In the presence of a black hole, every direction slowly tilts inward, creating a soft gravitational slope. Even light follows these curves, bending in wide arcs that reveal the invisible structure beneath. The closer one drifts, the steeper the curve becomes, until space flows inward like a quiet river entering a deep well. This curvature is not violent, it is elegant, continuous, and absolute. A black hole reshapes the world around it, not through force, but through geometry. An ever-present reminder that the cosmos itself has flexibility and depth. 5. The accretion disk, a slow, luminous spiral. Around a feeding black hole, matter often gathers into a glowing disk, a structure shaped by gravity, friction, and time. This disk is not chaotic, but rhythmic, moving in slow spirals that carry dust and gas into deeper orbits. As matter drifts inward, it warms gently, glowing in soft waves of radiation. The outer region rotates smoothly, while the inner region moves faster, pulled by the steepening curve of space-time. Together, they form a cosmic whirlpool, a serene vortex of drifting particles. Though bright from a distance, the accretion disk feels quiet from within. Its light a byproduct of gentle collisions and subtle heating. To watch it spin is to witness patience in motion, matter taking its time as it prepares for its final descent. 6. The whisper of Hawking radiation. Hawking radiation is the faintest voice a black hole ever speaks. It arises from the quantum foam that ripples along the event horizon, where pairs of virtual particles emerge spontaneously. Usually, these pairs annihilate instantly, disappearing as quickly as they appear. But near the horizon, one particle may fall inward, while the other drifts away, escaping into the universe as a soft whisper of energy. Over eons, this slow leakage causes the black hole to dim, shrink, and eventually evaporate. This process unfolds across timescales longer than galaxies survive, making Hawking radiation a quiet exhalation of existence. It is the universe reminding us that even its darkest regions participate in cycles of change. 7. The dilation of time. Near gravity's edge, time is not constant. It stretches, bends, and softens in the presence of gravity. Near a black hole, this effect becomes profound. A clock drifting near the horizon ticks slowly, its moments elongated, like gentle ripples frozen in place. To a distant observer, the traveler appears to stall, suspended between seconds. Yet the traveler experiences time normally, unaware of the stretching that surrounds them. This duality creates a serene paradox, two truths existing simultaneously. Near a black hole, time becomes a tranquil ocean, slowing into long, deep currents. It invites reflection on the fluidity of experience, the relativity of motion, and the quiet ways the universe shapes perception. 8. The dream of wormholes and hidden paths. Black holes may connect distant regions of space-time through theoretical structures known as wormholes. Though unproven, the mathematics suggests that deep within a black hole's geometry lies the possibility of tunnels stretching between far-off points in the cosmos. If stable, such a passage would create a serene corridor through folded dimensions. Movement through a wormhole would feel like drifting across a bridge woven from curved space-time itself. Even as a hypothetical idea, it captures the imagination, inviting thoughts of travel beyond stars, beyond galaxies, beyond the limits of linear distance. In the quiet gravity of a black hole, the seeds of interstellar passage might rest. 9. the silent collision of merging black holes. When two black holes drift together, their dance is slow and deliberate. They orbit one another for millions of years, spiraling closer as they release gentle waves of gravitational energy. These waves ripple outward, passing silently through stars, planets, and dust, stretching space as effortlessly as wind moving across water. As the black holes near each other, their horizons touch, merging into a single, deeper well of gravity. The moment of union is quiet, marked only by a final wave of spacetime rippling into the universe. Afterward, the new black hole settles into calm, its shape smoothing like a pond after two drops become one. 10. The fate of information at the edge of eternity. The black hole information paradox is one of the most soothing intellectual mysteries. When matter falls into a black hole, its structure, temperature, and identity seem to vanish forever. Yet the laws of physics suggest information cannot be destroyed. Does it remain on the horizon, encoded in delicate layers? Does it escape through Hawking radiation, stretched thin across centuries? Or does it slip into a deeper structure of space-time beyond our comprehension? The question drifts across quantum theory, like a meditative koan. At the boundary of a black hole, knowledge dissolves into gravity's quiet embrace, leaving behind a puzzle that invites reflection. 11. The gravity wells that sculpt entire galaxies. A black hole is not merely an isolated object. It is a sculptor of cosmic architecture. At the heart of many galaxies lies a supermassive black hole, millions or even billions of times more massive than a star. Its presence shapes the orbit of stars, the flow of interstellar gas, and the rotation of the galactic disk itself. Yet this influence is not abrupt or forceful. It is subtle, like a deep gravitational rhythm guiding the dance of billions of suns. Stars glide around it in vast ellipses, each orbit a quiet testament to the unseen mass that anchors the galaxy's core. Even gas clouds drift in patterns, sculpted by its presence, slowly feeding the black hole with gentle streams of matter. Over cosmic time, entire spiral arms may align with its gravitational pull, turning the galaxy into a living mandala of stars. Though hidden and silent, the central black hole serves as the galaxy's heartbeat, a steady anchor that holds the structure in place. Without it, the galaxy would feel loose, undefined, lacking the deep gravitational well that gives it shape. 12. The phantom echoes of gravitational waves. Gravitational waves are the vibrations of space-time itself, soft passing ripples caused by the motion of massive objects. When black holes merge or shift, these ripples travel outward at the speed of light, stretching and compressing the universe in subtle patterns. They pass through everything: stars, planets, people, yet we never feel them. Their motion is too gentle, too faint. Detecting them requires instruments so precise they can sense a change smaller than the width of an atom. These waves carry information not in sound, but in movement, like the quiet tremor of a distant ocean felt through the ground. When detected, they reveal the stories of black holes that collided billions of years ago, long before Earth existed. To listen to gravitational waves is to hear the soft memory of the universe, vibrations from ancient cosmic events, still traveling, still drifting, still arriving in the present moment from the depths of time. 13. The tidal stretching of stars. Near the abyss, as a star approaches a black hole, its shape begins to stretch under tidal forces. The side closest to the black hole feels a stronger pull than the far side, creating a slow elongation that resembles a luminous tear. This process is known as spaghettification, yet the term hides the quiet grace with which it occurs. To the star, the transformation might feel like drifting into a long, soft breath, gradually being drawn toward the horizon. Layers peel away like silk caught in a breeze, flowing toward the black hole in bright streams. The star's light flickers, forming a glowing ribbon spiraling into the abyss. Though the event marks the end of the star, it unfolds with an almost poetic stillness, a final surrender to gravity's embrace. What remains becomes part of the black hole's mass, adding a small whisper of energy to its eternal presence. 14. The cosmic mirage of gravitational lensing. Black holes bend light with such elegance that they create natural optical illusions across the universe. When light from distant stars or galaxies passes near a black hole, it curves along the warped geometry of space-time. To an observer, this bending creates arcs, rings, duplications, and distortions, patterns that look like cosmic mirages. These shapes evolve slowly, shifting as light travels and as the black hole moves through space. Gravitational lensing allows us to see objects far behind the black hole, almost as if space-time becomes a lens polished by gravity itself. Each lensing pattern is unique, a quiet signature of the black hole's mass and shape. In this way, black holes act like sculptors of light, turning straight paths into soft curves and revealing distant regions of the cosmos with gentle precision. 15. The serene geometry of rotating black holes. Kerr black holes, those that spin, introduce an entirely new level of elegance to the universe's geometry. Their rotation twists space-time like a slow cosmic whirlpool. Near them, space itself begins to swirl, gently dragging everything along in a process called frame dragging. A traveler approaching such a black hole would feel as though the universe were rotating around them, pulling their path into subtle spirals. This rotation also creates an outer region called the ergosphere, a place where space moves faster than any object could resist. Inside the ergosphere, energy can be exchanged, extracted, or redistributed, making rotating black holes some of the most intriguing structures in the cosmos. Their spin adds grace to their gravity, creating a tranquil but profound flow in space-time. 16. The infinite patience of black hole. Black holes grow slowly, feeding on matter that drifts too near their gravitational pull. Some may go millions of years without absorbing much mass, waiting in silent stillness for a passing cloud or star. Others form gentle streams of gas from nearby companions, drawing in matter that spirals inward through the accretion disk. This process is unhurried. A black hole may take billions of years to double its mass. Yet in cosmic timescales, this patience shows the natural rhythm of their existence. They are not hunters, but collectors, gathering remnants of the universe, one quiet moment at a time. Their growth represents a slow meditation on gravity, an accumulation of centuries, aeons, and eras, folded into the deepening well of their presence. 17. The event horizon as a cosmic memory surface. While the interior of a black hole remains unknowable, its surface, the event horizon, may hold the faint imprint of everything that has ever fallen into it. Some theories suggest that information is not lost, but encoded on the horizon itself, forming a thin, delicate layer of quantum structure. This holographic idea transforms the horizon into a kind of cosmic memory sheet, storing patterns in a form far beyond conventional understanding. To imagine this is to picture the black hole's boundary shimmering with quiet information, a surface alive with subtle quantum echoes. These echoes remain hidden, yet they preserve the essence of everything the black hole has touched. 18. The calm silence inside the photon sphere. Just outside the event horizon lies a region where light can orbit the black hole in perfect circles. This is the photon sphere, a fragile ring where the speed of light bends into a closed loop. A beam of light entering this region might circle the black hole many times before escaping or falling inward. For an observer, the photon sphere would appear as a glowing halo, a luminous echo of trapped photons swirling endlessly. Inside this region, time and space take on a surreal calm, forming a delicate balance between freedom and capture. It is a quiet arena where light dances on the edge of eternity. 19. The slow echo of lost stars. Every star that drifts too close to a black hole adds its story to the surrounding space. When torn apart by tidal forces, its remnants form long, glowing streams that spiral inward. These streams can persist for years, decades, even centuries, slowly fading as they merge into the accretion disk. Observers many light years away might witness these events as soft flickers of brightness, gentle rises and falls in luminosity that mark the star's final journey. The black hole absorbs these remains without sound, taking only the mass and leaving behind the memory of the star's light. These echoes are the universe's quiet reminders of transformation, moments when something bright becomes part of something deeper. 20. The deep stillness of the black hole. Shadow. The shadow of a black hole is not a physical object, but a silhouette cast by the bending of light. It forms where photons are unable to escape, creating a dark, round shape against the glowing background of the accretion disk. This shadow is the closest we can come to seeing the black hole itself, a window into a place where light surrenders. The shadow's edges are smooth and soft, shaped by the curvature of space-time. Observing it feels like staring into the universe's deepest meditation, a quiet pause where reality folds inward. This darkness is not empty. It is full of meaning, full of gravity, full of the silent presence of the singularity it conceals. 21. The quiet geometry of the ergosphere. Surrounding a rotating black hole is a region known as the ergosphere, a place where space itself is gently pulled along by the black hole's spin. In this area, nothing can remain still. Even light, drifting in from faraway stars, begins to swirl. To imagine the ergosphere is to imagine space-time behaving like a soft, rotating tide, slowly dragging everything with it. A traveler entering this region would not feel a sudden shift, only the subtle sense that their path is being guided, turned, influenced by a rotation woven into the fabric of the universe. The ergosphere is not dangerous. It is a cradle of curved geometry. It allows the possibility of extracting energy from a black hole's spin, as if space-time itself offers a slow, steady current of power. This region reveals the graceful complexity of rotating gravity, a structure both delicate and profound. A cosmic whirl where motion becomes a natural part of existence. 22. The soft drift of stars in a black hole's orbit. In the quiet centers of galaxies, stars drift around supermassive black holes in wide, elegant arcs. Their motion is serene, predictable, and deeply influenced by gravity's steady hand. These orbits are not chaotic spirals. They are smooth ellipses shaped by millions of years of cosmic balance. The stars move as if participating in a slow celestial dance, each step guided by the central mass that silently anchors the galaxy. To watch them from afar is to witness harmony, gravity, and motion in perfect union. Even as the black hole remains invisible, its presence is known through the calm choreography of these orbiting suns. Their gentle movement reveals a truth. Black holes do not destroy the universe around them. They organize it, shape it, guide it into patterns of quiet stability. In their shadow, stars find rhythm. 23. The eternal drift of black holes through the cosmos. Black holes are not fixed points. They move slowly, silently across the galaxy, drifting through star fields like dark travelers following ancient gravitational currents. Some wander alone, remnants of long-dead stars. Others migrate through the cosmic web, influenced by interactions with stellar clusters and galactic tides. Their journey is unhurried, spanning millions of years. As they travel, they shape the environment around them, capturing stray bits of matter and occasionally passing near stars that feel their gentle pull. A rogue black hole drifting toward open space may wander for eternity, untouched, unobserved, carrying its quiet gravity through the dark. Their movements remind us that even the heaviest objects in the universe are not anchored. They glide like drifting stones across a vast cosmic river. 24. The deep calm of the Schwarzschild radius. The Schwarzschild radius defines the size of a non-rotating black hole, the distance from the center at which escape becomes impossible. Though it sounds mathematical, this radius represents something much more poetic, a quiet boundary drawn by gravity. It is the simplest type of event horizon, perfectly spherical, perfectly symmetric, a pure expression of mass-curving space-time. This radius does not fluctuate or waver. It exists as a calm, geometric truth. Inside it, all paths lead inward. Outside it, space behaves normally. This boundary reveals the elegance of gravity in its most essential form: simple, absolute, serene. It is the universe's way of saying, here, the curve becomes complete. 25. The gentle fall of matter. Past the horizon. When matter drifts across the event horizon, the process is surprisingly peaceful. Contrary to imagination, there is no tearing, no jolt, no sudden disappearance. The matter simply continues along its path, following the curves of space-time. If the falling object were conscious, It might not even realize the moment it crossed the boundary. Time would feel normal. Movement would feel uninterrupted. Only the outside universe would see something different. The object slowing, fading, stretching into red light as its moments appear to freeze. This duality creates one of the universe's most calming illusions, a fall that feels natural to the traveler, yet eternal to the observer. 26. The subtle balance between order and chaos. Near a black hole, the universe balances on the edge of order and chaos. Gravity's pull is strong, but the motion of stars, gas, and light remains smooth and predictable. This balance reveals the quiet intelligence of cosmic geometry. Even in regions where space-time bends sharply, the laws governing motion remain clear and elegant. Chaotic turbulence gives way to smooth curvature. Violent forces are softened by the mathematics of relativity. A black hole's environment becomes a meditation on balance, between falling and orbiting, between stillness and motion, between the known and the unknowable. In this region, the universe demonstrates its deepest equilibrium. 27. The soft dissolution of light. Into gravity light, the fastest traveler in the universe, succumbs gently to a black hole's gravity. As photons approach the horizon, their paths bend into slow arcs, losing energy, stretching into longer wavelengths. Red becomes deeper, red, fading into infrared, then into invisibility. This transformation is not violent. It is a gradual dimming, like a sunset slipping below a horizon. Eventually, the light becomes part of the black hole's unseen archive, its energy absorbed into the flow of space-time. To watch this process is to witness one of the universe's most peaceful surrenders. Light transitioning into darkness without struggle. 28. The infinite patience of supermassive black holes. Supermassive black holes grow over billions of years, their mass increasing through quiet accumulation. They feed slowly, drawing in drifting dust, wandering stars, and occasional gas clouds. Their growth is steady but unhurried, reflecting the calm rhythm of cosmic time. Some remain dormant for eons, barely feeding at all. Others awaken with gentle brightness when nearby matter spirals inward. Across galaxies, these colossal objects serve as silent anchors, shaping structure and movement. Their patience is immense. They measure time not in centuries or millennia, but in cosmic epochs. Their stillness becomes a kind of presence, a timeless witness to the unfolding of galactic evolution. 29. The luminous jets that rise from the edge of darkness. Some rotating black holes produce powerful, narrow jets of energy that stream outward from their poles. These jets form not from the singularity, but from the swirling accretion disk and magnetic fields around it. Though energetic, their motion is smooth and coherent, like beams of light shaped by gravity's quiet mathematics. They stretch across vast distances, sometimes hundreds of thousands of light years, carrying particles at nearly the speed of light. From afar, these jets appear as cosmic lighthouses, marking the presence of the unseen black hole with gentle luminosity. Their existence shows that even near darkness, the universe finds ways to create dazzling, structured beauty. 30. The secret calm of primordial black holes. Some theories suggest that tiny black holes may have formed in the earliest moments of the universe, long before stars existed. These primordial black holes would be small, ancient, and scattered across the cosmos. Like quiet relics of the Big Bang, they might drift unnoticed through interstellar space, too small to significantly disturb their surroundings. Yet their presence, if confirmed, would rewrite our understanding of cosmic history. These miniature black holes could be the quiet fossils of creation, the oldest objects in existence, carrying with them the silent memory of the universe's beginning. They would represent gravity at its most delicate scale, tiny wells of space-time formed in the first milliseconds of time itself. 31. The dim halo of orbits. Inside the innermost stable circle, near a black hole, lies a delicate boundary known as the innermost stable circular orbit, often called the ISCO. This is the quiet edge where motion shifts from graceful orbit to inevitable descent. Outside the ISCO, matter can circle the black hole in smooth loops, drifting like soft waves, tracing a calm shoreline. Inside it, stability dissolves. A particle entering this region cannot maintain orbit, no matter how precise its motion. It begins a serene inward fall, following space-time's deepening curve. The ISCO is not a barrier, but a threshold, marking the last place where circular motion is possible. Its location changes depending on the black hole's isan, shrinking closer for rapidly rotating Kerr black holes and resting farther out for non-rotating ones. In this subtle ring, gravity reveals its gentlest limits, where the universe whispers. Beyond this, only the inward path remains. This boundary shapes the rhythm of accretion disks, the glow of falling matter, and the slow choreography of cosmic spirals. It is a silent architectural line drawn by relativity, a smooth frontier between motion and surrender. 32. The slow evaporation of eternal darkness. Black holes feel eternal, yet through the soft emission of Hawking radiation, They evaporate over unimaginable spans of time. This evaporation is not a dramatic release, but a slow exhalation of energy. For stellar black holes, the process may take 10 to the 64th power years or more, far longer than the lifespan of stars, galaxies, or even atoms. For supermassive black holes, the evaporation timescale becomes so vast that it stretches into epochs where the universe itself has entered silent darkness. As the black hole shrinks, its temperature rises, and its whisper of radiation grows slightly stronger, though still too faint to detect with any foreseeable technology. Eventually, after trillions upon trillions of millennia, the black hole releases a final soft pulse of energy and disappears. This gentle end completes one of the universe's longest cycles. In the far future, when the cosmos is cold and dim, the last black holes will fade quietly, returning their mass to the vacuum. Their evaporation marks the final chapter in the universe's grand story. Gravity's last breath, dissolving into the endless quiet. 33. The mirror-like symmetry of charged black holes. Reissner-Nordstrom black holes, those that possess electric charge, reveal a deeper symmetry in the universe's geometry. Their structure contains not just one horizon, but two: an outer event horizon and an inner Cauchy horizon. These layers form like concentric shells, each marking a new region of space-time. The gravitational well becomes more complex, shaped by the quiet balance between mass and charge. To an outside observer, the black hole appears ordinary, yet its interior contains intricate geometry. Gentle slopes, nested horizons, and potential bridges to deeper regions. Though natural charge black holes may be rare in the universe due to neutralization, the concept remains a beautiful meditation on symmetry. A charged black hole represents gravity woven together with electromagnetism, two cosmic forces blending into a single serene structure. In space-time diagrams, these black holes resemble mirrored gateways, hinting at hidden paths and layered depths. They remind us that black hole interiors may be far richer and more complex than their silent exteriors reveal. 34. The soft flow of relativistic time. Near rotating gravity. Near a rotating black hole, time itself is drawn into the spin. This effect, called frame dragging, causes clocks near the black hole to tick differently depending on their direction of motion. A clock orbiting with the black hole's rotation experiences slightly faster time. One orbiting against it experiences slower time. This creates a gentle temporal gradient, a flowing river of time shaped by rotation. To a traveler, the effect is subtle, almost imperceptible, yet profound. Their perception remains natural, but the universe around them shifts its rhythm. This delicate warping of time reveals the flexibility of reality, how rotation, mass, and motion blend into a single smooth continuum. Near a Kerr black hole, time becomes a soft, spiraling current, never chaotic, always ordered by relativity's calm equations. 35. The cosmic archaeology of star swarms. Near the core. Near supermassive black holes, dense clusters of ancient stars gather in quiet, swirling crowds. These stellar neighborhoods, called nuclear star clusters, form some of the oldest, most stable structures in the universe. Stars in these regions move rapidly yet gracefully, orbiting in close proximity without collision. Their motion reveals the mass of the central black hole with exquisite precision. Some stars travel so fast that their orbits complete in mere years, offering astronomers a way to map the invisible gravity well at the galaxy's center. These clusters act as cosmic archaeologists, holding the fossil record of galactic history in their motions. Each orbit is a story, a record of gravity, time, and distance woven across millions of years. 36. The faint glow of relativistic accretion winds. Near actively feeding black holes, streams of gas may escape the accretion disk in soft, warm winds. These winds are shaped by radiation pressure and magnetic fields, drifting outward in slow, structured flows. Though they carry enormous energy, their motion feels gentle, like heated air rising from a quiet desert floor. These relativistic winds regulate the growth of the black hole, sometimes preventing excessive feeding. They also enrich the surrounding galaxy, distributing heavy elements and shaping future star formation. Their glow, visible in certain wavelengths, forms a subtle halo, a quiet breath exhaled from the edge of darkness. 37. The hypnotic loop of orbiting photons. Within the photon sphere, light can circle a black hole in perfect loops. These orbits are extremely unstable, yet profoundly beautiful. A single photon might circle the black hole dozens, hundreds, or even thousands of times before escaping or falling inward. If a traveler could watch this phenomenon without falling, they would see their own image reflected repeatedly, stretched and curved in a ring of infinite echoes. The photon sphere creates the glowing outline seen in black hole images, a luminous halo born from trapped light. It is one of the universe's most delicate structures, a dance of photons moving on the razor edge of gravity and freedom. 38. The expansion of space. Around sleeping giants, even when dormant, supermassive black holes influence the expansion of the universe around them. Their gravitational fields create subtle distortions in cosmic structure, guiding how galaxies form, cluster, and drift through space. Over billions of years, these giants help shape the large-scale web of the cosmos. Their presence ensures that the universe does not expand uniformly, but with quiet complexity. Filaments, voids, clusters, and deep wells emerging from gravitational interplay. A sleeping black hole does not fade into irrelevance. It becomes part of the background architecture of existence. Holding 39. The hidden stability of the inner horizon inside certain black holes, especially rotating and charged ones. There exists an inner horizon, a second boundary separating regions of space-time. This inner horizon creates a layered depth, almost like chambers within the gravitational well. Theoretical models suggest that time and space behave differently here, forming calm yet exotic geometries. Though these horizons may be unstable in real astrophysical conditions, their existence in theory reveals the intricate architecture of relativity. The inner horizon is a quiet mathematical secret, a hidden room inside the cosmic cathedral of gravity. 40. The final mystery: whether black holes give birth to universes. One of the most mesmerizing ideas in modern physics is that black holes may be seeds of new universes, deep within the singularity, where density becomes infinite and space-time curves beyond comprehension. Some theories propose that a new expansion could begin, its own Big Bang, its own timeline, its own laws. In this view, every black hole becomes a silent womb, carrying within it the potential for creation beyond our reality. Our own universe might have arisen from such a singularity, birthed in the collapse of a star from a parent cosmos. If true, then black holes are not merely endpoints, they are gateways, transitions, cosmic bridges between realities. This idea rests on the boundary of science and philosophy, inviting quiet wonder. 41. The gentle pulse of quasi-periodic oscillations. In the regions just outside a black hole, matter spirals inward in waves that rise and fall with rhythmic consistency. These subtle variations in brightness, called quasi-periodic oscillations, reveal the gentle heartbeat of space-time near the abyss. The gas in the accretion disk vibrates, wobbles, and resonates as it responds to the deep gravitational curve beneath it. These oscillations are not chaotic. They follow patterns shaped by the black hole's mass, its spin, and the geometry of space-time itself. In their slow pulses, astrophysicists hear the quiet tremor of gravity at work, a steady rhythm marking the flow of matter toward the horizon. These oscillations are soft clues, hints of motion unfolding in a place where we can never truly see inside. They form like distant echoes, rippling through the hot plasma, reflecting the structure of space-time with each rise and fall. To listen to them is to listen to the black hole's breath, a calm repeating signal emerging from a region where silence otherwise reigns. 42. The infinite tunnels of maximal extension, space. Some mathematical descriptions of black holes reveal a deeper, extended structure beneath the horizon, an elaborate network of mirrored spaces, repeating universes, and symmetric pathways. This concept, known as maximal extension, suggests that the geometry of a black hole connects not just one interior region, but multiple layers of space-time arranged like reflections in a hall of mirrors. These hidden realms exist not physically, but as possibilities allowed by the pure equations of relativity. They are serene, continuous spaces, a landscape where coordinates stretch smoothly into unfamiliar directions. In these extended diagrams, the black hole's interior becomes a quiet labyrinth of vast rooms and corridors of curved geometry. Though no traveler could navigate them, they stand as a philosophical lens for imagining what lies beyond the limits of observation. Maximal extensions invite us to consider the calm complexity that may lie within gravity's deepest wells. 43. The horizon's soft glow. Through quantum tunneling, black holes appear perfectly dark, yet at the quantum level, the horizon shimmers with quiet activity. Virtual particles emerge, flicker, and vanish in the vacuum near the boundary. Through quantum tunneling, some of these particles escape outward, forming the faint glow known as Hawking radiation. This process is gentle, arising from the fabric of space-time itself, rather than from the black hole's interior. The particles drift away slowly, carrying tiny fragments of energy into the universe. To imagine this glow is to picture a calm halo of quantum events happening just beyond perception. It is a whisper of light emerging from a place where even light cannot escape. 44. The slow migration of black holes inside galaxy clusters. Within galaxy clusters, vast families of hundreds or thousands of galaxies, black holes drift with the slow gravitational tides of the environment. Over billions of years, supermassive black holes gradually sink toward the centers of their clusters through a process called dynamical friction. This motion is unhurried, almost meditative. The black hole glides through waves of dark matter, drifting ever deeper into the cluster's core. On their migration, they may merge with other wandering black holes, growing heavier, quieter, more ancient. Their path is shaped not by choice, but by the soft, persistent tug of collective gravity. These migrations reflect the universe's patient evolution, structures folding together, layer by layer, over unfathomable spans of time. 45. The circular calm of ring-down vibrations. After two black holes merge, the newly formed black hole vibrates with the softest of tremors. These vibrations, called ring-down modes, radiate gravitational waves in calm, dying tones. Much like a struck bell slowly losing sound, the black hole settles into its final shape through a series of gentle oscillations. Each mode reveals information about the black hole's mass, spin, and symmetry. The ring down is nature's way of smoothing the geometry, ironing out imperfections until only the perfectly curved horizon remains. These vibrations drift outward as faint waves, carrying the signature of the merger across space. Listening to them is like hearing the final sigh of a cosmic event, the universe closing a chapter in total stillness. 46. The deep slumber of dormant black holes. Not all black holes are active, feeding, or glowing with accretion. Many drift through the universe in a state of profound dormancy. These silent giants rest within galaxies, undetectable unless a star or cloud wanders too close. Their horizons remain cold and invisible, absorbing only the faintest whispers of gas that drift through interstellar space. A dormant black hole is the closest thing the cosmos has to perfect stillness. No light, no disk, no jets. Only gravity, quiet and patient. Its presence can be inferred only through the subtle motion of nearby stars or the soft lensing of distant light. For billions of years, such a black hole can drift untouched, never feeding, never stirring, content to be an invisible curve in space-time. And yet, its potential remains vast. With a single close encounter, an errant cloud, a wandering star, it can awaken, lighting its surroundings in a slow, rising glow. But until that moment arrives, it rests. Dormant black holes remind us that the universe holds not only violent events, but also an immense reservoir of calm, waiting, silent mass. 47. The gravitational memory stored in curved light. Black holes do not merely bend light. They store the memory of their presence in every photon that curves around them. When light passes near a black hole, its path shifts subtly, tracing arcs shaped by the invisible geometry of space-time. These curves carry information, hints about the mass, the spin, the structure of the horizon. Over great distances, the bending of light becomes a record of the black hole's quiet influence. This effect is known as gravitational lensing, and its patterns are as delicate as brushstrokes on a cosmic canvas. Sometimes the lens forms a ring, a perfect halo of curved photons. Other times it creates arcs, smudges, or duplicated images. These distortions tell a story in silence. They show where the black hole rests, how heavy it is, whether it spins. In the absence of visibility, lensing becomes vision, and the black hole becomes an artist shaping light into calm, repeating patterns that drift across the universe. 48. The soft rewriting of space. Through frame, dragging, near a rotating black hole, space-time does not remain still. It begins to swirl, ever so slightly, pulled along by the black hole's spin. This subtle twisting of space is called frame dragging. To imagine it, picture a vast sheet of calm water, and then imagine one slow, powerful vortex turning beneath it. The water begins to rotate, not violently, but with gradual persuasion. Near a Kerr black hole, frame dragging blurs the meaning of direction. East and west lose their independence. The black hole's rotation becomes part of the environment, woven into the geometry. A traveler drifting near the horizon would feel space shifting beneath them, gently reorienting their path. Frame dragging demonstrates that even emptiness can move, that vacuum can rotate, that the fabric of reality is not rigid, but soft, flexible, dynamic. It is one of the quietest and most beautiful predictions of relativity. 49. The subtle temperature of event horizons. Black holes, paradoxically, have temperatures. These temperatures are faint, far colder than the cosmic background, and arise from the soft whisper of Hawking radiation. A supermassive black hole may be colder than the emptiest reaches of space, with a temperature so low it cannot be felt, detected, or interacted with. Yet mathematically, it exists. This temperature hints at the deep link between gravity, quantum mechanics, and thermodynamics. It suggests that black holes are not mere empty wells, but thermodynamic objects with entropy, temperature, and internal states. The horizon becomes a kind of membrane, a quiet surface where information and energy interact in the softest possible manner. The temperature of a black hole is a reminder that even perfect darkness holds structure, laws, and quiet complexity. 50. The calm, echo of stars, born near darkness, near the centers of galaxies, where supermassive black holes reside. New stars can still form, despite the immense gravity, despite the swirling disks of gas, despite the inward pull. There exist calm pockets where gas slows, cools, and condenses. These regions give rise to stars that orbit the black hole in tight, graceful loops. Some move at astonishing speeds, completing full orbits in mere years. Yet their existence is serene, stable, balanced by the deep gravitational well that anchors them. These stars, often called S-stars, serve as luminous markers of the black hole's mass. Their light traces perfect arcs, revealing the invisible presence that rules the galactic core. The birth of stars in such a place feels almost poetic. New light blooming on the edge of darkness, forming peacefully in an environment defined by quiet gravity. 51. The silent oceans of gas that swirl in black hole neighborhoods. Around many supermassive black holes lie vast oceans of interstellar gas, soft drifting clouds that move with unhurried grace. These clouds are not chaotic storms, but gentle seas shaped by temperature, density, and gravity. Some patches of gas drift in slowly circling currents, forming the faint outer edges of accretion disks. Others remain suspended in serene equilibrium, warmed slightly by nearby stars and cooled by the darkness of space. Over millions of years, these quiet oceans of gas slowly migrate, shifting their shapes like cosmic tides. When gravity nudges them inward, they stretch into long, delicate tendrils that feed the black hole with soft streams of material. When pushed outward, they expand into broad, translucent veils that wrap the galactic center in calm, glowing haze. These clouds are the black hole's environment, a slow-breathing ecosystem where matter follows ancient patterns. To observe them is to witness the universe's patience, to see how even the faintest wisps of gas respond to gravity's gentle choreography. 52. The warm silence of relic disks. Around forgotten black holes. Some black holes no longer feed, yet faint remnants of their once active accretion disks remain. These relic disks consist of thin, cool layers of dust and gas that orbit in quiet, stable loops. They radiate very little energy, their glow soft and muted. Over billions of years, these disks slowly thin, spreading into wider rings shaped by microgravity and subtle collisions. They are like fossilized memories, traces of a time when the black hole was young and luminous. Relic disks reveal a peaceful stage in a black hole's life cycle, no longer devouring matter, no longer shining intensely. The black hole enters a long era of calm equilibrium. The disk becomes a soft halo around the darkness, a whisper of activity preserved in faint dust. These relic structures remind us that black holes change too. They age, quiet, and settle into long lifetimes of serene inactivity. 53. The gravitational whispers of orbiting pulsars. Some of the most precise clocks in the universe, pulsars, occasionally fall into orbit around black holes. These rapidly spinning neutron stars emit beams of radio waves with extraordinary regularity, sweeping across space like lighthouse beams. When a pulsar orbits a black hole, the timing of these pulses becomes subtly distorted. Each delay, each advance, each gentle shift in rhythm carries information about the black hole's mass, spin, and geometry. To study these changes is to listen to the gravitational whispers of the black hole, tiny fluctuations carried through space-time. Pulsars in close orbits transform into instruments of cosmic measurement, allowing scientists to map the invisible contours of gravity with exquisite detail. These systems form partnerships between extreme objects: a collapsed star whose rhythm never falters, and a black hole whose silent pull reshapes time itself. Together, they form one of the universe's quietest, yet most informative dialogues. 54. The soft tension between black holes and dark matter. Dark matter surrounds galaxies like a vast, invisible fog, shaping orbits, guiding motion, and providing the gravitational framework on which cosmic structure forms. Black holes live within this unseen sea, interacting with it in subtle, elegant ways. Though dark matter does not collide or radiate, it flows along gravitational gradients, drifting around black holes like silent currents. Over time, black holes may gather dark matter into gentle, dense halos surrounding their horizons, forming what physicists call spikes. These spikes deepen the gravitational well, subtly changing how stars move and how light bends nearby. The relationship between black holes and dark matter is quiet, delicate, and almost meditative. One influences the other, not through direct force, but through presence, a soft gravitational dialogue between the known and the unknown. 55. The ancient echoes stored in galactic cores. Every galaxy with a supermassive black hole carries within its center a long memory, an archive written in the orbits of stars, the shape of gas flows, and the quiet distribution of mass. These galactic cores have witnessed hundreds of millions of years of cosmic history, mergers, collisions, starbursts, and periods of calm. Through it all, the central black hole remains like a silent observer, recording each era through gravitational influence. The shapes of stellar orbits become fossil imprints of past events. The distribution of heavy elements whispers of ancient supernovae. Even the tilt and thickness of the galactic disk carry echoes of interactions long past. The black hole binds these memories together in its deep gravitational well. A galactic core is more than a place. It is a time capsule, sealed by darkness, guarded by gravity. In 56. The soft gravity wells of wandering. Intermediate black holes. Between stellar mass black holes and supermassive giants lies a mysterious class: intermediate mass black holes. These elusive objects, weighing thousands of times more than the Sun, drift silently through dwarf galaxies, star clusters, and intergalactic shadows. Their gravity is gentle compared to their massive cousins, yet strong enough to shape the motion of nearby stars. Many may roam freely, unanchored to any galaxy, relics of ancient mergers or collapsed stellar clusters. Their presence is subtle, an unexpected acceleration here, a faint gravitational lens there. Though they rarely feed, when they do, the glow is soft, long, and dim, like a candle flickering in a vast cathedral. These black holes reveal a transitional chapter in cosmic evolution, bridging the gap between the small and the enormous. Their lives unfold quietly, without the luminous drama of quasars or the turbulence of supermassive accretion disks. They are the wandering monks of the universe, solitary, serene, and steeped in ancient gravity. 57. The silent geometry of black hole. Spin axes. Every rotating black hole has a spin axis, a direction in space that remains remarkably stable across cosmic time. This axis becomes the backbone of the black hole's environment, shaping jets, winds, and the inner structure of the accretion disk. The stability of the spin axis provides a quiet order to the chaos of the galactic core. Even as stars drift, gas flows shift, and galaxies collide, the spin axis holds its direction with ancient patience. This consistency reveals something profound. Black holes may be the most reliable compasses in the universe. Their spin axes point like needles across millions of years, aligning jets, jets aligning galaxies, and galaxies aligning into filaments of the cosmic web. One silent axis can carve order from the turbulent motions of entire clusters. 58. The quiet tides of space-time. Inside binary black hole systems, when two black holes orbit one another, they create some of the most mesmerizing gravitational patterns imaginable. Their mutual pull shapes space-time into tides, vast, smooth distortions that rise and fall with each orbit. Unlike stellar tides, these are not made of water or gas, but of geometry itself. The space between the black holes stretches, compresses, and bends in rhythmic pulses. As the pair spirals inward over millions of years, their orbits tighten, their tidal distortions deepen, and their gravitational waves grow stronger. Yet throughout this long dance, their motion remains calm and predictable. Binary black holes are cosmic duets, two invisible masses tracing slow, elegant circles through the heart of darkness. Only in the final seconds, when they merge, does the rhythm crescendo. But until that moment, their partnership is a quiet ballet of gravity. 59. The soft dissolution of magnetic fields near the horizon. Magnetic fields, powerful and structured in most astrophysical environments, begin to unravel as they approach the event horizon. Their lines stretch, curve, twist, and finally dissolve into the deep curvature of space-time. This dissolution is not violent. It is gradual, graceful, a soft surrender of ordered gravity's pull. As infalling plasma follows the inward path, its magnetic structure becomes thinner and more fragile. Eventually, the field lines break, reconnect, or fade entirely as they cross the horizon. This process is essential for shaping jets, heating disk material, and regulating accretion. Yet, at the finest scale, it feels like a quiet erasure, a slow unwinding of structure, as matter transitions from the visible universe into the black hole's hidden interior. 60. The ancient shadow of the first quasars. In the early universe, when galaxies were young and gas was plentiful, some black holes grew rapidly into brilliant quasars. Their accretion disks glowed with blinding intensity, outshining entire galaxies. Yet surrounding each quasar was a vast region of calm darkness, a shadow cast by the black hole at the center. This shadow was ancient, one of the earliest footprints of supermassive gravity in the cosmos. As quasars faded over billions of years, these shadows remained as historical imprints, telling the story of the universe's first luminous giants. Today, only a few distant quasars still shine, offering glimpses into the deep past. Their shadows remind us that behind every burst of brilliance lies a quiet well of gravity, unchanged across eras, untouched by the passage of cosmic time.